Freshworks is a global leader in service management space, one of the fastest growing unicorns and a long-time Redis Enterprise shop. Freshworks has taken Redis to the next level and made it a part of each and every one of their services. Today, we'll hear from Sridhar Gade, VP of Engineering at Freshworks, about their Redis journey. Please give a virtual clap emoji round of applause as I hand it off to Sridhar. Sridhar, please take it away.
So before we get started, a little bit about me. My name is Sridhar Gade, and I've been working in the internet scale SaaS industry for close to a couple of decades. My primary role and responsibilities has been building internet scale products and the platform that support that particular product. So yeah, this is before the cloud era when we are talking about massive scale Hadoop clusters or compute, and then after 2010s we are talking about the cloud era where the global presence kind of mattered for all SaaS companies, and then it kind of worked through various different sizes of the companies, including Yahoo, Microsoft, and now Freshworks. And I also authored a book on career, the progression, and I have multiple blogs, and I write on LinkedIn. That's about me. And now let's quickly jump into what Freshworks is all about. So, Freshworks, it's a great company powered by great products, in turn powered by great engineering and technology. So the company started in 2010 and started with the Fresh Desk as a name as well as a flagship product. Fresh Desk primarily focused on customer experience related product, where we powered customer success and customer experience teams all over the world. So after that, we ventured into ITSM, business through our Fresh Service product, which is number two flagship product, where we started powering the IT and SRE and DevOps kind of employees within the company for them to be able to do change, product problem management, and a lot more using Fresh Service. Slowly, we moved to Fresh Chat and the contact center. These are the foundational capabilities that were built across our products right now, to see how do we make the products more personal and communicatable. Eventually, when you look at, we entered the CRM market with the Fresh Sales and Marketer to power your sales and marketing teams. So overall, with this group of products, we are talking about 360 customer vision, where we are powering customers of our customers and also employees of our customers, and all that is kind of powered by Freshworks Neo platform. It is again internet scale SaaS platform which powers horizontally all of our products. So there is a seamless transition and a seamless experience across the products, and the time to market is much faster, with this platform being at the center of all of our products. So that's a kind of a summary about Freshworks. So one of the fastest growing unicorns all over the world. At this point, we powered more than 60,000 customers across 100 plus countries, and we continue to grow across the world. And we also boast of ourselves of multi-cloud and multi-region and multi-tenant architecture company, and well sought after in the open source community as well. Okay, so with that, I will speak about some of the interconnect within the company in terms of the tech stack. This is very high level kind of 30,000 feet view, but if you look at on the left side, we got Freshworks products, different individual products that are there, and then we also have platforms which are more like a technology, like we're talking about billing, big data, email logging, which are actually required to power these products in a generic terms. And we have at the bottom of it, we have the cloud layer, where we got Kubernetes. We are talking about the database layer and all other good stuff, basically fundamentally. So this is fundamentally very high level view of platforms and services. Obviously super oversimplified, but this kind of gives an idea in terms of the kind of complexity the individual products have, and then what kind of subsets and technology that we need to use to kind of support this kind of scale. So now quickly moving into the scale of Freshworks, right? So like I said, it's a great company powered by great engineering. So we are talking about close to 10 million requests per minute across the entire company, which is ingress and egress. So before I talk about the numbers more, I would like to mention a service or a product that we internally built called Edge. So Edge kind of forms perimeter for entire production and non-production environments of Freshworks, and it kind of controls and manages all the incoming and outgoing traffic. So Edge basically watches all the traffic that is coming in. So at Edge we will be able to control the performance, control the rate limiting, and also it can be used as a security deterrent for the traffic that is coming in and going out. So with Edge being there, it's kind of a single place for us to be able to apply any kind of policies to be able to prevent noise in hyper situation, especially when you're talking about multi-tenant situation where at this point we are talking about 60,000 plus customers, B2B, B2C, all over the world, sharing common technology, sharing common tech stack, but be able to still isolate their data, isolate their communication completely mutually exclusively. And that's what is powered by the entire tech stack we just spoke about. But then Edge is the starting point in terms of security and the performance and availability for the entire product line. Now we just spoke about 10 million RPM across the products and services, and we also have P95 latency is tagged around 100 to 150 milliseconds, right? And one thing I would like to kind of call out is scale of observability, right? This is our ears and eyes into the entire production and non-production environments. We collect close to 13 trillion metrics per month, and these metrics come from all the entire tech stack layer from top to bottom. So we're talking about application layer and all the way down to like a physical layer, right from what is happening your database layers to your caching layers to APIs and front end, and even in some cases of third party integrations. So the data that is coming in, close to 200 terabytes per day, is kind of sliced and diced and provided in three different formats. The one is in terms of logs, where you'll be able to see with full granularity for the investigation. We got traces. This is for developers and their productivity to be able to do investigations and troubleshooting. And we have metrics. So metrics are very clearly defined triggers based on all the data that we have, be able to identify certain triggers and send that alert to respective teams like NOC or SRE teams, where they'll be able to receive it and be able to actually take an action. So these are the metrics, both proactive and reactive. Proactive metrics will help you kind of prevent or even detect the issues that are future, right? So using anomaly detection and the predictive analytics, you'll be able to actually foresee the outages that can potentially occur in the future using standard deviation techniques. We also look at the already occurring outages, which are basically, and then engage NOC and write teams to be able to reduce your TTX metrics, right? And then obviously we're talking about 2 petabytes of traces per month, and so these are the metrics. We are growing at the rate of close to 30 to 40% annually, on this scale. So this is at a bird eye view of the tech stack and the scale of Freshworks. So hopefully this gives a bit of context. Now we will kind of jump into what is the scale that we have for Redis and where do we actually leverage. So before we jump into that slide, I would like to just mention that looking at all the products that we spoke so far, the platform, subservice, and tech stack, pretty much almost all subsystems use Redis in some capacity, which means that we all know that Redis is used in various different use cases, could be caching, rate limiting. There are variety of use cases. So we pretty much use all use cases that are officially announced. Plus there are some extensions using modules. So and you're going to see that in the future slides that are coming in. So, and here are the certain some scale on the Redis. So we are talking about roughly 500 endpoints. This includes standalone sentinels and massive clusters which are powering our large scale products. And this number is growing as we speak. And we are talking about 2 billion plus keys that are stored, which are accessed in real time across our products. About 4 TB of memory that is provisioned. And but what's most important or the interesting fact in this slide is about we are talking about 1.5 million operations per second, and I think that's exactly is kind of intriguing for all of us. So while we build Redis into our infrastructure, we looked at caching alone, like in a few many years back, and after that we slowly start getting into message broker, where we are looking at a pub sub concept. How do we start using it? Because Redis is good at performance and very good at data integrity. So, and very rarely you see any kind of outages or downtime. So the reliability is much higher as well. So what else can we do? Then we started looking at leaderboards and ranking systems. And then, like I just spoke about, the message broker, but I think it also goes hand in hand with some kind of a jobs queue, like an MQ kind of scenario. We also started looking at geospatial indexing and full page caching and stuff like that. So all in all, Redis, I think in the future, slides we are going to talk about 2 or 3 very specific use cases, and hopefully that will kind of give a clear picture of where we are heading with this technology. So the apart from caching, rate limiting is one of the areas where we have leveraged Redis extensively, right? So we have a internal rate limiting system which is kind of attached to the edge, which is our peripheral the service, which is kind of watching and controlling every traffic that is going in and out of Freshworks network, and this internal rate limiting service is kind of attached to edge right after that. And then we use atomic counters to be able to look at every traffic that is going in and out. So the product of our rate limiter service will use these atomic counters to be able to start the counter or the read from the counter, just to be able to know what are the workloads that are coming in. And then also based on our historical data, we should be able to see if it is a malicious traffic or it's a legitimate traffic. If it is a legitimate traffic, then what are the different limits that we can allow before this particular customer starts to impact the other customer. So the rate limiting happens based on multiple different factors, but the top being we do rate limiting by domain names, rate limiting by the URLs, the full URLs, and also source IP addresses. So this also kind of helping us to avoid DDoS attacks coming from a particular IP address, where the rate limiting kind of halts the amount of volume that is coming from particular IP. There are certain areas where it is kind of legitimate traffic, but then we are able to kind of tune it in such a way that it kind of self learns and be able to take the scale up or down depending upon the past behavior of that particular traffic that is coming in. So we are talking about, again, in the rate limiting, again 4 billion keys, and but more importantly, we are talking about 0.5 millisecond latency. So that is what is required when we are talking about trillions of requests are coming in, and billions of requests are coming in on a daily basis. Any millisecond latency addition here is going to slow down the entire product or multiple products across Freshworks. And that's what we want to make sure that at this point, while this rate limiting is helping us a lot, but it's not being bottleneck for the every operation that is coming in going out. So the less than 0.5 millisecond latency is kind of really helping us, almost being transparent to the end user in terms of the performance. So, and then we got roughly 3 million ops per second, which is also significantly grew over last few years from few hundreds of Ks to almost 3 million ops per seconds, and it's growing significantly higher as we add more customers and more regions. So there is a production data happening, and there is also a DR. So we have parallel environments that are there in production, and then we also non-production. So everything is kind of channeled to this particular infrastructure. So rate limiter is one of the key the usage for us, and it's been working us very well for Freshworks. So now moving on to the powering the under the hood services, right? So we are talking about like background backbone of Freshworks is there are like hundreds and thousands of processes in the background that are running in various different priorities, and they all power our products, like depending upon it's a customer communication. There are different channels within the communication. You're talking about real-time phone calls, plus then there's chat messages, there are web, and there's mobile communications are happening in the background. So here we are talking about close to 700,000 jobs every minute as we speak, and all these jobs are powered by Redis, and in three different areas. Like you could see, there are real-time jobs where customer or the user is using it on the website and the job needs to get triggered. Like, okay, so the response time should be in real time. And the second one is scheduled. So we also have hundreds and thousands of scheduled jobs. Basically, be able to do maintenance activities or generate reports of that sort. And then there are long running ones where it could be a counter, which is basically it's a daemon which is sleeping, but kind of like keep waiting. I think it's just in a wait state for certain exceptions to happen, so that you can wake up and execute certain action. So these are the long running jobs that are also there. So all these are kind of baked into sidekicks, and we have again hundreds of sidekick installations that are actually created within Redis, and because of its reliability or the speed and performance, we are able to just scale it very continuously, and it's actually working very well. One thing I want to also call out here is invisible scaling. It is especially in case of IO threads, the way the Redis subsystem capacity manages internally, depending upon what my current workload is. So when I have low to moderate workloads, a certain type of IO threading, but then the moment I actually get to the higher workloads, then the threading automatically optimizes just to make sure that I have a consistent experience. So I think the under the hood management, job management, and IO thread management, I think fantastic. So that kind of works for kind of all classes and all scales of companies, depending upon what kind of traffic that is coming in, and what type of jobs and volumes that are being kind of executed. So this is about powering our sidekicks. So right now we are at 700K, but we see this touching much higher numbers very soon, because with every new feature being added, we are talking about this number going up exponentially. The next scenario we are talking about going beyond traditional use cases, right? So in general, we just spoke about multiple use cases, but then we also have the modules which will kind of extend its use cases. First one is the Bloom filters. So Bloom filters could be used in multiple different scenarios where I would like to know if a particular record exists in a DB without going to DB and asking for it, right? One real-time use case that I can think of is whenever we have the kind of an attack on us. So the traffic comes in, the attacker knows our URL, the FQDN, say www.freshservice.com, but then they start adding invalid extensions to the URL. So now, when the moment the right FQDN is entered, or rate limiter, and the edge kind of passes it through, but then since that URL is not valid, it ends up leaving the cache and goes to the right, the database at the backend, and that's the easiest way you can actually choke the database and then bring down the entire company, because that's a DB that is also powering legitimate traffic as well for validating the URLs. So the Bloom filters essentially will have a list of items that do not exist in the database, and then basically they block the traffic right there, and any illegitimate URL that is coming in, it gets through edge, and then it hits the Bloom filter, and then obviously it gets black hole there because it doesn't exist in the database anymore. It's kind of a trial and error. It took us some time to actually build that, and it's not totally foolproof, but it reduces the possibility of being vulnerable to an attack dramatically. right? So that's a Bloom filter. And then the second use case we are talking about the modules is search. So it's a traditional search. So depending upon what module we are in particular product, it could be product search, and it could be some feature search. But since it's all in the memory resident database, it becomes a lot more easier and faster for us to be able to search through all our content. And this is another area we have leveraged it very extensively across the board in multiple different scenarios. So apart from out of the box modules available in with Redis, we also looked into building some of our own, right? In-house modules. One of them is basically rate limiting service, which is something new that we want to use the latest features of Redis and see if we can actually build something that is much more faster and go it can give us a better performance and take higher scales. So we have been successful in implementing that, and we'll be able to share more data as future as we run it into production. But this is one of the scenarios where we were able to extend the functionality. And then there are a few more areas there we are looking into OSS as well as the marketplaces of Redis to see what else is actually useful for us. So as you can see, so there is no stone unturned in terms of leveraging across the board in terms of what functionality we are using, except if it is completely different use case like in analytics where we need a different type of performance, or the use case if it is supported even remotely by Redis, we have it. So with that, we something interesting, right? So no technology presentation is complete without talking about generative AI these days. So we saw the tsunami of LLMs that are coming into the market. So the ChatGPT kind of came and kind of disrupted the market. But then LLMs have been in place for many years in the past. But there was a traditional AI, and then machine learning concepts have been there. So now we are talking about generative AI, which is totally a different paradigm, and it is able to take instructions in a natural language and be able to do massive computing. So while we work with large companies like Microsoft, OpenAI, Google has Vertex, and we have Amazon. Now they came up with a Bedrock with the in-house LLMs called Titan, and Amazon also kind of provides access to Anthropic and various other Hugging Face and various other open source LLMs as well. So these are the large companies who are providing us LLMs, but at the same time, can we do caching, right? If we don't do that, then if you are using a commercial LLM like say Azure OpenAI, it's going to be super expensive, and also in terms of both cost and performance, because every token that is being generated from your network is actually going out and coming back. So in that context, the vector database concept actually comes into place. There are multiple players in the market. So all we are doing is, in the traditional world, when we want to index unstructured data, a data which is like images, that could be videos, there's a text. So how do we put all of them into one particular database and then be able to search? So in the earlier world, we have to tag them based on certain keywords, and once the tagging is done, so whenever we search, certain combination of keys are kind of picked up, and the result is displayed to you. But it's not very efficient. It could be, it all depends upon how, what the quality of tagging, and also as the complexity of your content goes up, it becomes more and more difficult for us to be able to get to the right content and right file. So to work around that, now with the generative AI, so we are talking about vector database where you kind of convert these indexes into kind of kind of numbers instead of keywords. So and these numbers will have distance metrics like L2 cosine, and a distance could be in multiple dimensions. So you could have anywhere between 2 or 3, and it can go up multiple dimensions. And pictorial, you can show up to 2 or 3 dimensions, and beyond that it's not possible for us to show it in any kind of representation. But in the system, it is possible to manage hundreds of dimensions, and in each dimension, the database kind of groups these objects into kind of a likelihood of being together. Like there are fruits, there are flowers, there are human beings, different traits. So the vector differences will be much lower for like kind of matching objects versus the other objects. So this kind of makes it easy for whenever you are doing kind of a search, it's easy for people to go and fetch a similar object. Uh, so I think with Redis working as a the vector database, what can happen? It's already great with the content, all the features we spoke about, and the caching and counters and the message queues and everything else. But now in this new world, imagine a scenario where I have a use case where I need to have hundreds of knowledge base articles kind of summarized and into probably like maybe 100 pages of knowledge base articles summarized into a single page or maybe few paragraphs for my customers use, right? So in the normal case, all the 100 pages need to be sent to your LLM host provider, which is Azure OpenAI or Google Vertex, for example. And then you pay for all the tokens that went through, and then the return. So this is called prompt. So whatever you prompted, basically you get charged, and then all the response that comes back also is charged depending upon the model that you use, LLM model. So and this repeats each time we do it. So when we introduce the vector database in the middle as a as a broker or as a middleman, every traffic that kind of goes in also gets indexed here. So you have vector embedding stored in this database, and then embedding data is kind of passed on to the LLM. So next time when there is a similar request for the same kind of content is asked, so the content is actually served from your vector database but doesn't go back. So which means you end up saving on both round trip performance as well as the cost. So this, when you actually look at the at scale, this can translate it to hundreds and thousands of dollars in terms of the cost. And we also talk about a round trip when we do it at like in a massive scale. We are talking about a round trip. Even the millisecond matters a lot. So and this database keeps learning, and with when we are talking about here, the hybrid filtering or range queries, all these different search methods will make it more and more easier for people to pull the content in and use it. So like I said, there are other players in the market. They're open source and then commercial, and this is the new tech that is growing right now as we speak. You can use OpenSearch, for example. You can use different other tech, but end of the day, Redis being a memory resident database, it like very likelihood of giving you better performance is much higher. So that's in terms of the AI and LLM world, how Redis can actually help. So and can help you actually save both cost and like round trip performance, right? Especially at scale. So apart from this, Redis is also getting into multiple different use cases as far as the LLMs are concerned. So as you embed more features into your products, which are it could be on your customer experience product, it could be your CRM product, you may be in healthcare or your financial domain. There are multiple use cases that are emerging. So I think this database will, I think, continue to learn and give you kind of a performance and throughput that you're actually looking for. And last but not least, companies are actually already looking for multiple LLMs, kind of being LLM agnostic or LLM neutral or cloud neutral. And when we have that, we can actually kind of mix and match commercial and open source LLM models. Like open source, you could take something like a Falcon 40B and kind of mix and match with Azure OpenAI, and both these models being in the backend, but can use the same Redis vector database and tuned for the similar use case for a particular model, which could be text summarization, right? Now, Falcon 40B good at text summarization or working as a codex for you giving code generation, but depending upon what use case you're using, while there are hundreds and thousands of LLMs, open source LLMs available on Hugging Face, for example, if you go to the leaderboard there, but if you kind of mix and match the models that do the similar functions, then you'll be able to actually use a one single database in the front, where the end user experience might vary a little bit, but you'll be able to actually have a lot more freedom and flexibility in terms of, in case if there is an outage with Microsoft, you'll be able to automatically switch to the open source, or if there is an issue with the performance or any other change related outage in open source, you'll be able to switch back, which means your user will have continuous uptime and persistence and continuous reliability as well. So that way, this is at the center, and it's actually kind of making it transparent to the end users as well as your developers. So with that, basically, at a summary, I would like to kind of summarize what are the basic takeaways of all these benefits that I've just spoke about. So first one is scaling without downtime, because there are very few components in our infrastructure can be scaled without downtime, especially when you're talking about the growing companies like Freshworks. It's very difficult to kind of predict your what kind of scale we can expect, for example, 3 to 6 months down the line. But at the same time, it's not wise to keep it at a higher scale, anticipating more traffic to come in, which basically you're leaving the money on the table for our cloud providers. Which means I want to be able to tune it to a level where I have only maybe 10 to 15% of headroom, but when I actually hit my 90% plus, then I should be able to scale seamlessly. Redis allows you that. User management, I think it's a universal truth, much easier to do it. And the best part is multi-purpose. We spoke about at least 3 very solid use cases, and then with AI, 4th use case, apart from the traditional use cases of caching or rate limiting and other areas. Redis. So we were talking about cache, queue, counters, and persistence. Persistent data store is another use case where the Freshworks extensively deployed Redis, right? So also think about the ease of operation. So most of the companies invested in SRE and DevOps teams, and every time you introduce a new technology, the amount of time and efforts involved in hiring and training your workforce is extremely high. And sometimes success of your team or success of your company depends upon how good is our hiring, and then how we are actually nurturing them. Otherwise, your reliability can go down. Number of outages can kind of increase, and your internal and external users will start to suffer. So with this ease of operation, I think the learning curve is pretty sharp. I think pretty flat, and that kind of helps people to quickly learn this technology and be able to support, and that greatly in a longer term helps use of this technology. Obviously, there's a community and language support. In Freshworks products, we support anywhere between 25 to 50 different languages all over the world across our different products. So it's very important for us to be able to support all these languages in the geographies. And then last but not least is the modules for extending functionality, because so we have a limited set of features for Redis, and based on what release we use, what level of Redis we use, we basically use certain functionality. But then without looking for next version of Redis, we still be able to extend the functionality. All I need to do is just go to marketplaces, look for the kind of module that I need, and then get it and kind of deploy. So these are all in all, I think, a high level summary of benefits. But I think I'm kind of with the limited time that we have, we are able to kind of summarize all these benefits. So if I hope this kind of made sense for a company which has gone from talking about 5 to 10 customers 10 years ago, and now we are talking about 60,000 plus customers, and close to crossing a $500 million mark on revenues, but then accelerating very fast, close to 100 plus countries, serving all these customers. But then Redis being at the center of this tech stack is only accelerating our growth, and will grow even faster. So with that, I'm kind of concluding this presentation, and I hope it was useful and informative.
Thank you so much, Sridhar. I'm glad to see Freshworks leveraging Redis as a vector database, with an eye to the next round of innovation. It's great to see those performance numbers of millions of operations per second, with sub-millisecond latency at terabyte scale. That is a true testament to the greatness of the engineering team of Freshworks, and we're excited that Redis is a part of that legacy.